Hello and welcome in video lecture series Demystifying Blockchain. In this video, we will try to understand the Bitcoin UTXO model. In order to understand UTXO, we will first go through transaction structure in Bitcoin. Okay, so let us start. If you look at the diagram here, say this is transaction A, okay, this is transaction B, and this is transaction C, and finally we have transaction D, right? So focus on transaction A now. What is inside a transaction? You will find always there are inputs, okay, and there are outputs. Now try to see in every transaction you will find input and you will find output. There is only one special transaction that is called as coin-based transaction where there are no inputs. Okay, so which one among these four transactions is coin-based transaction? This is transaction B, right? Because you will not find any inputs here. You will only find outputs. No inputs but only outputs, right? Okay. So what is this coin-based transaction? In previous video where we have seen when a miner is able to successfully mine a block, he is being rewarded by the protocol, that is Bitcoin protocol, with a reward called as mining reward. And for that he includes a transaction to self, that is he includes a transaction that pays him. This transaction is a special transaction and this is the only way through which new Bitcoins are being created, right? So this transaction is called as coin-based transaction. So no input is required for those transactions, and this is the way to increase the supply of Bitcoin, right? But we have also seen that the supply is fixed. It will be only 21 million and 2140 is the year when last fraction of Bitcoin will be mined, right? So we have understood two types of transactions now. One are very special transactions that miners only are able to do that once they successfully found the new block, right? Mine the block. So that is based upon whole process like proof of work, consensus mechanism. Okay, but you see now look at other transactions. There are inputs, right? There are inputs. If we look at transaction A now, there are input as well as there is output. Okay, so in order to understand those things, what is this input there, right? So this is basically an output of a transaction, previous transaction, right? That could be anything, output of a transaction. And this is also output of a transaction, any other transaction, right? Now what we are doing here inside a transaction A, we are creating another output, right? From those inputs we are creating an output. So basically the main point here is to understand that transaction is basically set of inputs and set of outputs. So what are those inputs? These inputs are basically the outputs of other transactions. So now we have reached to a stage where we'll say we first look at what is UTXO. Okay, so this is abbreviated as unspent transaction outputs, right? Unspent transaction output. Now what is this unspent transaction output? These are those outputs of transactions which have not been spent. Simple meaning, right? But look at this and just ignore this transaction is not there, right? Transaction C is not there. You will see the output this output, and you will see output this, but you ignore about transaction C and D for now. You just see we have transaction A and transaction B. They are creating two outputs. One is the output of transaction A here and another is output of transaction B. These are UTXO until we don't spend them, right? Now in transaction C we are spending them because we are referring those outputs here as an input. We are referring this output as an input here. So this we can't call them now UTXOs, right? Because they have been spent now. But what is the current UTXO here? If we look at all those four transactions, transaction A here, transaction B here, transaction C here, transaction D, look at this output. As per this diagram, we are not using this output as of now. So this is UTXO, that is unspent transaction outputs. So the model of Bitcoin working is based upon this UTXO, that is you will be utilizing those UTXOs in order to create further transactions, right? When I say some account A is having 3.12009 BTC, that is Bitcoins. What does that mean? That means he has that number of, like, he has UTXO which corresponding to this value, right? So that is which if we look at here, if this is the address A, like that account A, so he has an UTXO which has the value of 31.20, right? So that means this account will have the power to spend this transaction, right? If we take an example now, if this transaction, we create another transaction here, right? We create transaction E. Okay, what we are doing here, we have to use input. Okay, we have to use input, and we have to create an output here. What input we have to use any particular transaction as an input. So I am directly using transaction D as my input. That is basically I am trying to utilize this output here, right? So I have inside this much of balance to spend. If I say like this, then I have completely utilized all those UTXO value, right? So this transaction D is, this output is not UTXO now. Why? Because I have utilized it after transaction A. So this is how transactions are carried in Bitcoin. So we have seen the chain of blocks, right, where every block is connected to its previous block. So this is basically blockchain, right? But there is a chain of transactions as well. These are transaction chains, right? Because if you look at this transaction C is using input from transaction A as well as from transaction B. This will be like this: transaction A, transaction B are being utilized by transaction C. Transaction C outputs are being utilized by transaction D, right? So this way we have a chain of transactions. That brings the transparency. Suppose if any account at particular instant tries to spend some Bitcoin, he will refer to the output of previous transaction, right? Because that would have been UTXO. He will refer to that, and that in turn will refer to its previous transaction. That in turn will refer to its previous transactions, and ultimately we will reach to a stage where it will stop, because that transaction would be a Coinbase transaction. It will stop at a point where we see that this transaction has been mined, and this is a Coinbase transaction, just like here, right? So if we come from transaction D here, right, let us take another example for much more simplification. We go to transaction D, and we want to just see where from this input comes in, right? It comes in from transaction C, output index 1. If we start from 0, then it's 0. If we start this will be index 1 then, right? So we will directly say this is from transaction C with index 0, right? Because index is here 0. Now I have seen transaction D is using output from transaction C, right, with index 0. So transaction D input is coming from transaction C, right, the output of transaction C with index 0. Now if we look at transaction C inputs, we have multiple inputs here. One is coming from transaction A, other is coming from transaction B, and with the index 0, because there are single output, right, in both of these transactions. So what we can infer that transaction D, if we can straightway see the source where from these Bitcoins that are being utilized here in transaction D, they come from the output of transaction C. So where transaction C is referring to utilize those outputs, because that this output is based upon two inputs in transaction C. So we can straightway reach to a point like transaction A and transaction B. But in transaction B, we can stop here. We can say, okay, these are Coinbase transactions. But in turn, we have to look into transaction A, where from transaction A is getting those inputs, right? We can reach to other transactions here. And finally, we can reach to a stage again where they are Coinbase transactions. Because now we can say that these coins have been mined authentically, right? By going through a dedicated process called as proof of work, right? Because that is the only way of creating bitcoins, and that transaction will be coin based transaction, or you can say coin generation transaction. If we look here, say it's a generation, right? Why transaction C is using two inputs here, right? Why not single? This can be understood by taking a simple example where we have the job of sending amount that is more than more than a single UTXO value. Suppose if 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 transaction C has to send 8 BTC, right? Just for the sake of understanding, 8 BTC as an output here. What transaction C does? It's basically an account, right? He has two UTXOs. One is coming from transaction A, second is coming from transaction B. If we sum them, but single transaction is less than 8, so this transaction output cannot satisfy our need because of 8 BTC. Here we have 6.102, right? You consider 6 only, right? Just for the sake of simplicity. But single UTXO will not satisfy our need because we have to spend 8. Then what transaction C does? He will sum up whatever UTXO he has. So he cleverly decides that he will choose these two transaction outputs, UTXOs, and this sum comes out to be something 12.352, right? Now this is more than 8, okay? This is more than 8. He has created 8 here. Whatever is left, like 4.352, he has to change it, right? What does that change means? He is sending it back to your account, back to himself, okay? So this is how we do change of bitcoins when we have requirement. That is, so we have 10 bitcoins, we want to send 7, but single UTXO does not help. We have to use 2 UTXO, and whatever is left, we create another output for that is called as change, and whatever we want to set, we can have another output as a fee, right? So if we don't specify anything, then that will be taken as a transaction fee, and that goes to the miners. So that is like how transactions are being done. So we see these are like, there are inputs. So multiple inputs could be there depending upon the need of an account, right? If account wants to transfer more than what he has in single UTXO, he has to use multiple inputs, and he will create outputs depending upon the requirement. If he wants to send to multiple addresses, he will create multiple accounts. But what are those inputs? These are basically UTXOs, right, which have not been spent until this transaction has been created. So these UTXO will be used, right, to create outputs, and those outputs will become UTXOs for other accounts. So this is how we say Bitcoin transaction model is based upon UTXO, unspent transaction outputs. In next video, we will actually look at how Bitcoin scripting works and how we can spend those UTXO. So that will be quite interesting video. So if you like the content, hit the like button of the video and subscribe to my channel. Thank you.